All right, welcome to the Explainer. Today, we're diving headfirst into a real cosmic mystery. We're talking about an interstellar visitor that is just breaking all the rules.
Okay, so picture this. An object from another star system, an object that's actually older than our own sun, is paying us a visit. And no, this isn't science fiction. We've got a real interstellar comet right here in our cosmic backyard, and let me tell you, it's turning everything we thought we knew completely on its head.
And it's not exactly taking a leisurely stroll. This thing is absolutely screaming through our solar system at a mind-bending 130,000 miles per hour. I mean, just to put that into perspective for you, that's fast enough to get from New York to LA in less than 2 minutes. Wow.
So, what exactly is this thing? Well, you can think of it like a cosmic time capsule. It's carrying secrets from a star system that's light years away. And as you're about to see, it is leaving a trail of some seriously baffling clues.
Right, its official name is 3I/Atlas. But trust me, this is not your average run-of-the-mill comet. It's a total anomaly, a cosmic outlier that's basically forcing scientists to go back and rewrite the textbooks. So let's just jump right in with the first of many, many bizarre clues.
Okay, so our very first clue comes from something that's never, ever been seen before. We're talking a first in astronomical history. It's a feature so completely unexpected that it has scientists just buzzing with a mix of excitement and, a whole lot of questions. The XRSM satellite picked up something, well, extraordinary. It's this massive X-ray halo just enveloping the comet. And we're not talking about some small, faint glow here. This thing is a colossal structure, 400,000 kilometers across. I mean, get this, that's wider than the entire distance from the Earth to the Moon. So you might be asking, what's causing this massive glow? Well, it's basically a reaction between particles flying off our sun and the comet's own gassy atmosphere. And what this reaction reveals is just stunning. These X-rays act like a chemical fingerprint, and they're showing us the presence of carbon, nitrogen, and oxygen. Yep, the very building blocks of life. But hang on, because the mysteries are just getting started. Astrophotographers started taking pictures of this thing, and they saw it was glowing with this really brilliant green light. Now, for most comments, you'd say, okay, green glow, pretty normal. But for 3I/Atlas, it's a total paradox. And this is where it gets really, really weird. See that classic green comet glow? It's almost always caused by one specific molecule called diatomic carbon, or C2. It's like the standard explanation. But when scientists actually analyze the light coming from 3I/Atlas, they found that molecule is either completely missing or it's there in such tiny amounts that it can't possibly explain the glow. A real head-scratcher. So that leaves us with this massive blinking question mark, right? What is causing that green glow? The working theory right now is that the comet's totally unique, alien chemistry is creating some kind of light show we've just never seen before. We literally don't have an explanation for it yet. And believe me, the weirdness just keeps piling on. The surface of this comet is alive. It's erupting, spewing out these incredible spiral jets of ice and gas. They call it cryovolcanism, which is just a fancy way of saying ice volcanoes. Super cool. It also has two totally distinct tails. But here's the part that's really blowing minds. Some of these jets are actually pointing forward, ahead of the comet. That just completely flies in the face of everything we know about how comets are supposed to behave. Okay, so all of that is strange enough. But honestly, maybe the most profound thing we've discovered about 3I/Atlas is what's actually inside it. And this discovery connects directly to one of the biggest questions we could possibly ask. Where did life come from? So, scientists pointed the ALMA radio telescope array at it, and what they found was startling. The comet is just venting these huge clouds of methanol gas. We're talking about 8% of its total vapor is methanol. To be clear, that is 4 times more than any comet we've ever seen from our own solar system. And why is that a big deal? Well, because methanol isn't just any old chemical. It's a really key organic building block for life. So the big takeaway here is that 3I/ATL is basically a flying factory, churning out the precursors for life. It's absolutely loaded with both methanol and hydrogen cyanide, two of the most essential ingredients you need for what's called prebiotic chemistry. The chain of chemical reactions that scientists think led to the very first life here on Earth.
And a discovery like this, it really adds some serious weight to this old, long-debated theory called panspermia. The basic idea is that the building blocks of life aren't just unique to our little corner of the universe. Instead, they could be a kind of cosmic inheritance delivered to young planets like ours by interstellar visitors. Well, just like this one. Okay, so a comet with this unique chemistry and all this bizarre behavior, that's already pretty strange, right? But now let's talk about its trajectory, the actual path it's taking through our solar system. Because when you factor that in, the mystery gets even deeper. And it's leading some people to ask a pretty provocative question. Is this just a random rock? So, according to Harvard astrophysicist Avi Loeb, the odds of this thing's path just randomly aligning so perfectly with the very edge of Jupiter's gravitational influence, it's a zone called the Hill radius, are, get this, 1 in 26,000. That is a staggering statistical anomaly. It's the kind of number that's really hard to just brush off as a coincidence. And this really gets us to the heart of the debate about 3I/Atlas. So on one side, you have the mainstream scientific view, which is that, look, it's just a natural object. A very weird and rare one for sure, but still natural. But on the other side, you have Loeb and a few others arguing that the trajectory is just too precise to be a simple coincidence. They've pointed out that its path looks suspiciously like an optimal path for something called an Oberth maneuver, which is this really complex but super efficient way for a spacecraft to use a planet's gravity to slingshot itself, maybe to drop off some probes. Now, to be clear, the vast majority of the scientific community is firmly in the natural origin camp. But this perspective from Loeb really highlights why the comet's path continues to stir up such serious and, yeah, definitely controversial discussion. It's a statistical puzzle. So all of these questions, all these mysteries, it's all creating a real sense of urgency for scientists. And why is that? It's simple. The clock is ticking. Our time to study 3I/8 is running out because this cosmic visitor is not sticking around. We've got a few key dates coming up. The comet's closest approach to Earth, that's going to be our best look yet. Then, in February, we get all the data back from the JUICE spacecraft's flyby. And finally, that big encounter with Jupiter in March. That's going to be a make or break test for its trajectory. These are it. These are our last, best chances to get some real answers. Because after it swings past Jupiter, that's it. The comet is going to fade back into the darkness of interstellar space. And any secrets we haven't uncovered by then, well, they'll be lost to us. For good. For all of human history. So in the end, what is 3I/Atlas? It's a messenger. It doesn't really matter if it's a 1 in a billion natural wonder or something else. It's carrying a message, one written in molecules and light. And that message is a powerful reminder that the chemistry of life probably isn't just some local invention. It's part of a much bigger cosmic story that we're only just beginning to learn how to read.